So if you're looking to simplify rational powers, okay, I'll do a couple examples and then have you do some as well. What's going to happen is you're going to be given numbers or fractions generally that have perfect powers in the numerator and or denominator. Okay? You need to be able to recognize those perfect powers. Okay? And then you're going to apply them, apply the rules of whatever the rational powers are to that. Okay? And what that means is you might see something like this. In this first problem, I see 8 over 27. 8 and 27 are both perfect powers. 8 is 2 cubed, 27 is 3 cubed. Okay, so if I think of them in terms of those, what I can then do is apply the rational power and the rules of exponents. So here I know that a power applies to all parts of its base. So this negative 2/3 is going to apply to the 2 to the third. When you take a power to a power, you multiply. So I get 2 to the 3's cancel. I get a negative 2. All over, when I apply it to the denominator, again, the 3's cancel. I get 3 to the negative 2. The negatives are going to move my base. So my 3 gets moved up squared. My denominator gets moved down 2 squared. And so I wind up with 3 squared, which is 9, over 2 squared, which is 4. Now, you can do them in different orders. You can apply the negatives first. Okay, so let's say I jump down here to do this. If I applied my negative power, the negative of my power first, notice my negative is going to stay out front. My negative power is going to flip my fraction, so it becomes 8 over 1 to the positive 2/3. So again, in this case, I applied my negative power first. And then I can apply this rule. 8 is, if I wanted to in the same step, I could rewrite that, is a perfect power, 3 cubed, or 2 cubed. And so when I take a power to a power here, this 2/3 applies to the base 2 cubed. So I have my negative out front. My 2 to the 3 times 2/3, the 3's cancel, I get 2. And so my simplified form is negative 2 squared, which is 4. And that would be my solution. Okay, I'm going to do one final example and have you try the remaining 3. Okay, so let's say my base wasn't a fraction to start with, but I did have a negative power. If that was the case, again, I can think of this 256. You do want to recognize that that is a perfect power. Again, being familiar with them is helpful, but 256 is 4 to the 4th. Okay, so if you think of this as applying the negative, 1 over 4 to the 4th, all to the 3/4. So all I did was apply the negative first. I'm then going to take the power to a power. So 1 to the 3/4 is just 1. 4 to the 4th to the 3/4 when I multiply power to a power, or when I take a power to a power, I multiply. So this 4 and 4 cancel, leaving 4 cubed. 4 cubed is 64, so I get 1 over 64, and that would be my simplified form. Down here, one of the other ways that you can apply these rational powers is to think of them in their radical form. Okay, so if I was solving this problem using that strategy, what I could do first was I could apply my negative first, my negative power. I'm going to keep my base the same, but it inverts, becomes a negative 27 to a positive 4/3. And what I can do here is I can apply the fact that this index of this denominator of 3 represents an index, so I could say the cube root of negative 27 is what? Negative 3. And so I have negative 3 to the 4th. Negative 3 to the 4th gives me an overall value of 81, and that would be my solution. Okay? If I did the same thing here, I could either think of this as 1,000 is 10 cubed to the 1/3 and use powers or properties of exponents, or I can say this is the cube root of 1,000. The cube root of 1,000 is 10, and I can get my answer directly in that form. Okay, once again, with negative powers, I would generally apply the negative first, so this becomes a flipped base. 125 gets moved up to the 2/3. And then if I applied the cube root of 125 is 5. 5 squared is 25. And so if you're doing it that way, it's again just more mental calculations. Okay, but you can also do it with exponents.
Isn't it a negative 2 or like negative 2/3?
The negative flipped the base,
Oh.
so the base went from 125 to 1 over 125 to 125, and that's where the negative applied.
In the computer, can you put in negative 3 to the 4th? What does that mean?
It should be able to do that, but here's the numbers that you need to be familiar with. Okay, you need to be familiar with perfect squares up to 12 squared. Okay? You need to be familiar with perfect cubes up to 6 cubed, which is 216, 5 cubed 125, 4 cubed 64, 3 cubed 27, 2 cubed 8. Okay? The perfect powers of 4, you should know that 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256, and 5 to the 4th, 625. Okay, and then beyond that, 2 to the 5th you should be able to, and 3 to the 5th would be the other ones that you might need to sort of recreate. And if you were to say, you know that 2 to the 4th is 16 times another 2 gives you 2 to the 5th, and 81 is 3 to the 4th, so times another 3, 8 times 3 is 24, the 1 times 3 is 3, and so those would be the other ones that you might need to know.